Hello Geometry, this is Mr. Owsley coming at you with another video. We are down to our last two remote learning assignments, and I thought we would end on a very fundamental note. I'm just going to be talking to you guys about how to graph linear equations when they're given to you in slope-intercept form today, and then tomorrow I'm going to be talking about how you graph them if they're not in slope-intercept form. So let's begin. My apologies, by the way, for the grainy graphs. That's just the way it went, so try to stay with me on it. Okay, so first of all, guys, recognize that y equals mx plus b is sort of our template for graphing any line. The m represents the slope, aka the rise over run. The b value represents what's called the y-intercept. In simpler terms, I've just always called it the starting point because it's usually the first point that we plot when graphing. Okay, so just to make sure we've got a few things covered, this right here is our y-axis. Our vertical is the y. The x-axis is the horizontal one right here. And if we can get it so that y is by itself with the x term first and then the b term last, the b term, by the way, is always the constant. It's not multiplied by x. We should be able to use this info to plot some points. So let's check it out. Our first one is y equals 5 minus 2/3 x. I would say use the commutative property right away to flip those two around. So 5 minus 2/3 x is the same as minus 2/3 x plus 5. Okay. So our starting point is going to be 5. So that means starting at the origin, we're going to go up 1, 2, 3, 4, 5 units and plot a point. So b is equal to a positive 5. Our m is going to equal negative 2/3. Now, sometimes students, when they just see the negative in front of the fraction, they ask themselves, is it the top that's negative or is it the bottom that's negative? And the answer? Well, in order to achieve a negative number, you have to take a negative divided by a positive. So it's negative 2 over a positive 3. Or you would take a positive divided by a negative. So if we've got those two as equally correct slopes, that just means we can go down 2, then right 1, 2, 3 to plot our points. And we can do that multiple times. So from there I can go down 2, right 1, 2, 3 again. Or we can go up 2, left 1, 2, 3 and plot points. So there's our first line. And that's that. Let's check out number 2. Number 2 is already given to us in slope-intercept form. By the way, they call it slope-intercept form because it's written with the slope first, then the y-intercept second, slope-intercept form. Right away, we get that m is going to be a positive 4/3, and our b value is going to be negative 6. Here's my y-axis, here's my x-axis. B means start 6 units below the x-axis, so go down. Look, I'm sorry, it's really hard to see what 1 unit is on this, but I can kind of make out what's going on here. So go 1, 2, 3, 4, 5, 6. I'm going to say 6 units down is about right there. And then I'm going to go up 4 units, right 3 units. So up Let me make sure I got this here. Oh boy. Up 1, 2, 3, 4. You know what? I'm going to go up 4 twice. So I'm going to go up 8, and then I'm going to go right 6 to solve this problem. Because it seems like I can kind of make out what's going on up here better than down here. And that's one thing you can do to kind of like on the fly figure out what to do if these situations arise. So instead of going up 4, I'm going to go up 8. So if we're 6 below, now I'm 2 above, and I can see it pretty clearly right there, okay? And instead of going over 4, or I'm sorry, instead of going over 3, instead of going right 3, I'm going to go right 6. 1, 2, 3, 4, 5, 6. Okay. You guys won't have that issue because you'll just be making up your own graphs. You won't even be using the grids. All right, let's check out number 3. Not much to this lesson. All right, the difference here is you've got 2 whole values. So y equals 2 plus 4x. My first move is going to be to use the commutative property to flip them around. Okay, we are now in slope-intercept form. I'm also going to say whatever my slope value is, I want to represent as a fraction. I want to express 4 as a rise over a run. So if ever you get a whole number that's attached to x like that, just call it 4 over 1. Okay? So I don't even need to rewrite it. I've got it in slope-intercept form now. So my m value is going to be positive 4 over positive 1. My b value is going to be positive 2. So that means I start 2 above, 1, 2, on my y-axis. And then I'm going to go up 4, right 1. So up 1, 2, 3, 4, right 1. Now note, to get a positive 4, you can take a positive 4 divided by positive 1. Or you could take a negative 4 divided by negative 1. That rate of change will give you the same points on this line. So I can go down 1, 2, 3, 4, and then I can go left 1, and that's still a point on that line. And I could plot a few others, but based on how grainy this graph is, I'm not going to go for it. All right, we're just rolling through these now. How about number 4? So we had 2 whole numbers. Now we've got 2 fractions. The first thing I'm going to do is rewrite it so it's in slope-intercept form. Again, using that handy-dandy commutative property. Positive 3/4 x minus 4/5. Now, sometimes students are like, oh, find a common denominator. We got fractions all over the place. That's totally unnecessary and probably going to be counter to what you want to do. Y's by itself. So, we have the slope. It's 3 over 4. It's the thing attached to x. And then the starting point is negative 4/5. Now, whenever somebody sees a starting point that's a fraction, they tend to want to use the opposite strategy for plotting it. Like with m, you see a fraction, that usually indicates to you, oh, go up 3, right 4. But when they see a b of negative 4/5, they tend to want to say, oh, go down 4, right 5, and plot your first point. But does that make any sense? The b value is the place where it crosses the y-axis. If you went down 4 units and right 5 and randomly plotted it out here, I don't think that's on the y-axis. It needs to be on the y-axis. So really you need to think to yourself, if it's negative 4/5, that means you're going down 4/5 of a block. So let's say that a whole block is right here. 4/5 of a block is very close to it, but not quite. So we would plot our first point above -1 on the y-axis. Okay? So you go down 4/5 of a block, then you count up 3 from that point. So up 1, 2, 3, right 1, 2, 3, 4. And you could go the opposite way. Again, grainy graph doesn't make that so usable right now. But if I have at least 2 points, I can connect the dots. All right. So if you had 2 whole numbers, no sweat. If you have 2 fractions, no sweat. So I'm actually going to just let that one alone, number 5, because I just want to go through the examples that are absolutely necessary. Number 6. This one looks a little different. Notice there's no b value. If there's no b value, you need to assume that, hey, the mathematical equivalent to nothing that's showing up is +0. Okay, that just means that it starts right on the origin. And then it's going to go up 1, right 4 from that point. Up 1, right 1, 1, 2, 3, 4. Or down 1, left 1, 2, 3, 4. Okay, that covers how to graph a line given in equation form. Now, sorry, that was a little slow. What do we do if we're given the line itself and the instructions? The instruction above read, write the equation of this line in slope-intercept form. So they're basically saying, given the fact that this line is plotted out for you, and we know that y equals mx plus b is the template for any linear equation, can you fill in for the m and the b based on the line you're given? Hopefully the answer is yes. Because we've got these 2 points for sure plotted on our graph. We know it goes through those 2 ordered pairs. So where does it start? It starts at 1, 2, 3 above the origin on the x-axis. So it starts, our b is going to be +3. Yeah, you can just plug it right in there because we know it goes through the y-axis at 1, 2, 1, 2, 3. Now, the m is the rise over run. All right, so it's the rise over run. It rises or falls 1, 2, 3, 4 units down. So it falls 4 units, -4, and it runs 1, 2, 3, 4, 5, 6, 7. 7 right. So it's a +7. I guess I can just leave it like that. Nothing to it. All right, I'm going to stop right there. I think I've got the point across. So if you want to do number 8 on your own, the answer to that was y equals 3 over 1x plus 1. And I gave half the answers to you guys and then assigned it's sort of like an even odd split. So email me if you have any questions. And hopefully this video was helpful.